User group, welcome. Um, Glad to see you guys back. Any new faces? Any new timers here? Great, welcome. If you want to keep updated on what our activities are, you can go to our website, SFDUG and subscribe to our mailing list, and then you're going to get the notifications of our activities and the schedule of the speakers as well as the recordings. Our email and Twitter accounts are on the screen. We're always looking for speakers, so if you're doing anything nice on your end and you want to present, feel free to reach out and we can put you on the pipeline. So today we have a great topic, great speakers. I'll introduce them in a minute after I do some announcements. Now let's see. Today we are featuring the node of the month, the adaptive component node, and that's going to be presented by Arman Hadilou. He's our newest member on the SFDUG committee. So that's how we'll start the meeting. A lot of the committee members are going to Autodesk University this year in Las Vegas from November 11th to the 14th. There is going to be a computational design symposium on November 11th. So I don't know, anybody going to AU? Autodesk University? 1, 2? So there is a beginner's workshop and an advanced workshop. I'm going to be in the advanced workshop, and if anybody happens to be there, just say hi. We're going to try also to recruit more people to the group and try to find new speakers for next year. So because of this activity happens right at the middle of the month, there's not going to be any meeting in November. So we will do early next year a recap of what was new and exciting on the Dynamo front at Autodesk University. So stay tuned about that learning presentation in a forthcoming meeting. But in December, we have a great speaker. We will feature Zach Cron from the Dynamo development team. He's going to present what's new in the Dynamo 1.2. Apparently, there's been a flush of new features, 110 new nodes, and he's going to give us a summary of what are those new functionalities and what has changed. So stay tuned, don't miss that. I think it's going to be December 8th or 7th. We did it early because December is always a busy month, full of activities, so it's going to be the first week, I believe. So don't miss that session. It's going to be an exciting one. Our friends at the AIA San Francisco sent me a quick email to remind you also that the AIA Leadership Conference is coming up. If you want to learn more about it, just go to AIA San Francisco and sign up. And also, our friends from Gen MEP, if you haven't heard of Gen MEP, it's a product developed by Brett Young that enable users in the MEP side to create automatic routing of ducts. And he's featuring this Friday a free webinar about Dynamo and Gen MP. So if you're interested, just go to the website, buildingsp.com. The webinar is at 10 in the morning. Brett has also agreed to serve as a speaker next year when he has a much refined research on the Dynamo front, so stay tuned as well. And again, thank you to IDA for providing the food. They're always generous with pizza. So. All right, having said that, I'll pass the controls to Arman for 5 minutes, He's going to do the note of the month, and then we'll switch to our featured speakers. Let's see. All right, you're the presenter.
Hello, everybody. So we are going to look at the panelization method in Dynamo that we are going to get an adaptive component which has been modeled with a set of parameters, and then we set that component on a replicate the component on a panelized surface, and then start manipulating those parameters with new values within the Dynamo. So I would just get a quick demonstration of how the component is set itself and what are the parameters within the component. This is basically just an aperture that with the values for the size of opening, and those values can change independently just to give different size of the to the fenestration in the facade. So the parameters that have been set are basically the offset from the boundary of the component itself, which changes from 0 to actually 0.5, because it's basically reparameterized based on the 0 to 1 value for the component. So this is the structure or the bones of the component, and we can actually manipulate it here, and then we can see the reference lines have been set here. So what I'm going to do is that I'm going to just grab this component and place it on a subdivided surface here in Revit and start changing those values. And I'm using Lunchbox package for panelization of the surface, as well as collecting those parameters from the components. So basically, if I want to start from the beginning of the script, I'm just getting the edges of slabs just to make the surface, and then creating a surface with loft along those two edges. Then with the panel code, I'm just making a rectangular shape of grid on the surface, which can basically change. I can start adding to those values, and then increasing the resolution of the facade here. And then so those, just close that one. Those subdivided points on the surface are working as the armature, or the reference points for the corners of the components, and then feeding into the adaptive components with point node. We are basically making making our scheme here. And then from there, I have seen it two ways. One is just grabbing the parameters from the component and then starting adding values here, which is different values for each side of the panel. So, and these would be would change from 0 to 0.5. And also, the other way that we can manipulate those panels is by setting up an attractor point and start feeding the distance from the attractor point to the panels, which now the panel's dimensions would vary from one side to the other based on the proximity or the distance from the attractor point. And then there is a just code block that is lacing the values with the parameters. That basically these are the parameters that are set in the components, and these are the new values that we can start changing them here. And my friend Brian Combisi helped me to just set up the code block here. But we can start, and so the screen itself is kind of summarized or shortened. Doesn't have to be different set parameter by name. Just for each value, it could all be laced to get the parameter, and then set the values for each parameter. So that's it.
Great. Do you know if Dynamo now has out of the box the adaptive component node in the last versions?
For making a subdivided surface, or
for placing adaptive components?
I haven't checked 1.2, but I doubt that's. I'm not sure. I have to check that.
Oh.
You're saying like versus the lunchbox node?
Yeah.
Mm-hmm. I think it.
Would be nice, right?
Yeah, it would be nice.
That's how everyone else is doing it right now, is using lunchbox to do that.
Yeah. All right. Any question for our man? Great. So let me introduce then our speakers. Let me pass you the ball back then to myself. All right, we have two great speakers for today. We have Glenn Katz from Stanford University. He's a well-renowned academic with a large trajectory of learning material online. He's done great things for exposing his classes to the Dynamo community. I want to welcome him. And I also want to welcome Rommy Joyce from Bearington Studios. I believe you guys been working together on testing the new workflows for Dynamo. And the topic they are presenting is evaluating and testing design strategies. Let's welcome Len. I'll make you the presenter.
Sounds good. Something show up that says accept.
Yes. Can you switch off your... There you go.
Apologize for that. I thought we had it turned off. Okay. Thank you. I know. Actually, how much time do we have? So on like
7:30?
7:30? Oh, no problem. Okay, we'll be in great shape. We'll get you out on time. Thank you all for joining us.
Can you share?
Oh.
Let's go to
What do I have to do now?
share tab, upper left.
Wait, the tabs at the top?
Oh, have you?
Yeah, I'm going to try sharing my desktop. That is. Let's see if that works. Yikes, my email. You don't want that. That will just scare you. Okay, here we go. Okay, thank you all for joining us. I'm Glenn, and I am joined tonight by Rommy, who I worked with very closely at Stanford. One of my students in classes, and we worked on a workflow that we want to share with you that kind of used Dynamo, and we thought was a very creative, innovative approach to solving a problem Rommy had. I'm also joined by Shahan, as you over here. Shahan's been working with us on the same project, helping to extend it a little bit. He's been writing some of the new code and nodes that are kind of working in the background today. So, I just want to share the experience so they can see what the users group is like. Okay, so in getting going, have a seat, guys. We'll explain the context first and then show you a lot of specific stuff. The context was really all about, well, I'll let Rommy explain it in more detail, an urban planning problem and trying to think about how to approach using Dynamo to generate different alternatives for what city layouts could look like, what layouts could look like, and just different sort of approaches to how we place buildings and the height of the buildings on the sites. We were working on a project for the city of San Jose where that was an issue, and we wanted to look at a lot of different alternatives. Okay, and in doing that project, we rapidly realized, as we were trying to apply Dynamo, that you had to kind of approach it in a very systematic way. That as you tackle many big problems, just trying to put everything in one gigantic graph with a million pieces of connecting links really quickly becomes cumbersome, and it's very constraining in terms of how people can share and work on the model simultaneously. So we sort of came up with a general approach to really decomposing the problem and building it in a very modular plug-in way that could then be applied and easily extended. Okay, so what's going to happen is Ronnie's going to talk a lot about her specific example. I'm going to keep on chiming in about kind of more from a computer sciencey standpoint what we were trying to do with the modularization and kind of setting up some standard interfaces. Okay, so Ronnie, why don't you go ahead and explain your poster to us first?
Yeah, so Glenn mentioned it before. What we're trying to do is to create several different alternatives in the various development which is located in San Jose. And in order to test and finally pick the best alternative, we have to take a lot of time. It took us a lot of time to...
We can sit much better.
Sorry about that. So for us, it took a lot of time to do the layouts manually and so on. So we needed to find a more fluent, more automatic way in order to test several different alternatives. So, like Glenn mentioned it before, we came up at this with 4 different modules. One is called the layout generator, which pretty much focuses on the land use strategies. So it helps to create different alternatives, layout alternatives in different urban areas. And it pretty much has 2 parts. One of them is creating blocks, and the other one is creating lots. And then once we have that, we are able to generate buildings pretty much the second one is based on that, where you have a set of rules that will allow you to pick the type of building, the height of the building, and so on. So once we were able to implement that, we could move on to analyze and test these different alternatives. Obviously, there are several different tests that we could generate. One of them could be the energy use intensity. The other one could be evaluate the open space of these developments and so on. So it's up to the user to figure out what kind of analysis or test will perform in this kind of developments. And then our final goal is to use these alternatives and tests and pretty much optimize it and compare and contrast and figure out the best alternative from all of the alternatives that we have created. So pretty much this is the flow of the Dynamo setup that we have created.
So just to sort of position it, as we're thinking about Dynamo, we're trying to use it to rapidly generate the alternatives, and we're really trying to encode the information about how people are designing what strategies they're using as different little Dynamo nodes, so that we can swap them in and out very quickly to kind of test different potential strategies. It's all getting towards just the notion of generative design, and really can we use computers to generate many, many alternatives that we can test, programmatically, as opposed to having to generate them one at a time. So relating this back to even like we were here last year, today we're doing something very simple in terms of just iterating through many different alternatives, but you could ultimately plug this into more of an optimal sort of optimization scheme to try varying several different things and use an algorithm to zero in on the best values. But that's in the future. This is still pretty computationally intensive, so right now we're settling for just iterating through and reporting some values, which is still better than doing it manually. So that's a start. Okay.
So now we're going to show you our proof of concept, and we pretty much created a simple Dynamo script with some simple urban rules.
Good. So we're going to walk you through each of the different modules. The idea is they're going to keep on building sequentially, starting with the beginning of the problem, just laying out, if you were given a site, how you actually lay out blocks on that site and encode those sorts of rules. So let's switch on over, close that on up. Close that on up. Use those, and I think, well, there's the Dynamo and there's the site, so go for it.
So the first thing that we did is to figure out the limits of our development. In this case, we created this regular shape surface, and the idea is that you could, with this script, you could take that surface and divide it into several blocks. So I'm going to show you.
So just for context, where did that surface come from? What is that surface?
It's supposed to represent the areas of development.
Okay, so we took a map and traced the boundary.
Yeah,
and,
yeah, more or less, because obviously it's a simplified version of the areas of development.
Okay.
And what you see here, it's pretty much the bar station. It's the future bar station in Berryessa, or in San Jose, pretty much.
So one of the strategies that the city wanted to test is it's kind of like the attractor strategy. It's this whole notion based on where the BART station is going to be, should we sort of somehow alter the development patterns to take that into effect, so right around the BART station you have a really vibrant, kind of very city or pedestrian-friendly sort of space, and maybe kind of take some of the larger development and pull it away from that. So,
the Bearington station? Is that the last
This is a little bit farther north than that.
Oh, okay.
Yeah, so Berryessa, it's actually where the flea market is right now.
Okay.
Driving.
I just happened to be working on a project near the Bearington station, so it was interesting if that was the site. Okay.
This is
Sorry.
the next in the dark one. The Bearington station, sometime in our lifetime, maybe. I don't know. Actually, you know better.
I don't know.
Okay.
No secrets to share on that.
So for us, it was really important to have the limits of the development, obviously, in order to figure out the type of buildings or the dimension of the space that we're going to get the buildings. Okay, so what we have here is pretty much the first module, which is the block generator, we call it that way. And left, oh, yes, on the left where you see all the inputs. And over here we have a custom node that pretty much takes the site, divides it into blocks, given the set of rules that you provided. In this case, we are telling the width of the street, how wide the streets have to be. We're telling how the dimensions of the blocks. Obviously, in the future, this could be more complex, where because in the city or development you have streets, you have alleys, and so on, the dimensions change. But in this case, it's just one dimension for all the streets.
And so from a workflow perspective, the idea was to really pull out all the inputs so they'd be incredibly visible and give this to anyone. You can spot anything you can change that would have the effect, and then really take all the coding that's doing the back of the house stuff and put it into a custom module that would then be swap-outable. You could almost hot swap them to try out different strategies, but it wouldn't change the overall workflow because you'd be changing the module that's loaded in. So that's part of our style. Always thinking about modules and the interfaces between them.
Mm-hmm. So if we open this custom node, what we see it's well, you see that something is not even downloaded on this computer, but still. You can see pretty much the flow is the same. We divide it into several different chunks. So the first one is obviously the input, and the next one is just to try to figure out the form of the site. In this case, it's a regular shape, and it will try to figure out how to create these blocks, or how to pretty much take this site and place these blocks in this case, in a rectangular form. So we haven't make it this very complex. So once it takes the outermost points, it figures out what the maximum x or what the maximum y is on, and pretty much creates this block grid. In this block, what we have is pretty much that.
So we're clicking into a nice rectangular grid. One thing that happens down there at the bottom is this thing that says a line block. That's something we had to do at the tail end because our version of a rectangular block and how the site is actually oriented sometimes get out of whack with each other. So we had to have the ability to basically select some line that we wanted to say was going to determine what the rectangular grid would follow.
So you pretty much see here we have this guideline, line over here. So we're pretty much telling this function to align all these blocks to this line. So that's pretty much what it's doing, and the idea is that you could use that angle to align the buildings as well in the future if you want to. If you want the buildings facing that specific road.
Now, this scheme necessarily is kind of simple. It's just a rectangular grid based on sort of the street distance and width of the street. The idea is that you could plug in some other module that starts to sort of go for a more organic form that would follow the topo surface or rounded streets or any of that. But at some level, the workflow is independent of all that. You can kind of plug anything you want into there. This thing's just going to spit out block polygons, and then we're going to subdivide those.
Yes, unfortunately I cannot run it because I have to download one of the custom nodes files. Okay.
That's X. We should load that in there. But no, don't worry about the hot demo. Do you have like a Revit file? Yeah.
Yes. Let me open another one.
So you're taking in some of the land use parameters and setbacks from that plot and incorporating that into this node, or just kind of breaking it?
At this point, it's strictly like the attractor function.
Okay.
It's just kind of doing it based on closeness. But that is, again, that would be something you'd want to factor in, kind of this complex of factors where the closeness, as well as the land use, as well as maybe other uses that are nearby, and maybe even some randomness. Like Shahan was working on some of that to try and say that it's not strictly deterministic.
So as you can see over here, this is the final layout, pretty much. But as you can see, what the block generator is trying to do is to pretty much create the script on this surface. As you can see, I gave the script a specific number for the width of the script, and I told the script obviously how wide or what the length of the block should be. And so at the end, this is what is going to basically how it will display or how it will create those blocks.
So what do you do after you lay out the blocks? What's the next step?
So, let's see.
It's up there.
So the next step obviously is to create the lots on each block.
You're trying to open a new graph. You're trying to open a
Open a new one.
Pardon me, there's always technical difficulties. We swapped over between the different machines because Rommy's machine decided he didn't like the network so much. But we'll figure this out. No worries. Okay, let's go back out and get Dynamo open again.
So the tech point is obviously is trying to figure out where it's going to place the buildings. And in this case, it's also a grid. It's really simple, but in the future, we're trying to create more complex urban planning strategies in order to create a neighborhood that is more dynamic or reflects what a city should look like.
So the first step is just taking the blocks and dividing them into lots, which lots, how you want to think about that. And that is like, oh, how many in the width, or how many you want to put, how many deep you want to put in there. You know, you come up with all sorts of like strategies that sort of say about, different buffer zones, which is alleys between the lots. There's all these sort of different like sub things about what we do to subdivide it into sort of buildable parcels. And that's kind of the second step is just break it into parcels, sort of figure out what that layout is, and then we'll get to the buildings.
Yeah. So here's the block, here's the block, that's how we call it.
So what kind of parameters did you put in there so far?
So what I'm asking is to divide it into this grid where there will be on one side there will be three. I'm pretty much divided into columns and rows, so it will be a 3x4 block.
Okay, very good. And again, that's kind of a simplistic strategy. It kind of worked well enough, but you can imagine something that's really a much more sophisticated about minimum size of lot or maximum size and trying to sort of subdivide things nicely. But yeah, you need to be able to focus on that within the module and swap that out.
Yes. So what we have here is pretty much what we are trying to do there. Again, we are missing one person more.
Always the danger when you move machines.
So, as I mentioned before, we're dividing it into those sectors, and then we are trying to make sure that the buildings and that we have created are within the boundary. This is very much what it is. So, again, this is something that the user doesn't have to see. So this has to be within a certain let me see. Yeah, that's it. That's pretty much what we're doing here.
So the problem here was that a lot of the lots sort of ended up being outside the boundary. So we didn't stop it. We let the lots block be regularly shaped, but then when we put the lots on, we figured out either you're in or you're out. There's only a little Boolean filtering to kind of like to sort of assess.
Yes. So that's pretty much what we have here. Great. And then once we have that, the next step is obviously to figure out the building scheme that we're going to use. We talk about the height of the building, we're going to place on these lots. And this building scheme could be as simple as the one we have created because we use a simple relationship, a linear relationship, where the buildings that are close to the attraction point will have the highest. It will be higher than the ones that are within a certain distance from the attraction point.
Okay, so as an urban planning strategy, that's putting the really high density stuff right up against the BART station. Maybe making little canyons around the BART station, but actually putting a lot of people who are working and living very, very close to it. Hopefully trying to increase it. But maybe decreasing the livability or the viability of it a little bit. It might not be so nice to be that dense. But that's what we wanted to explore.
So I will show you what I think most of us are kind of familiar with the attraction point. Pretty much is going to do that. The height of the building will vary, and obviously in the future people could create more complex modules, and this could be more sophisticated. Yes.
Are you ready?
I'm looking for Dynamo.
Oh. Okay. I think it probably isn't open anymore, right?
Yeah.
So it's still open. Okay. The problem with hot swapping the files under Dynamo is Dynamo doesn't like us. Pardon the flashing. Oh, come on, dude.
So here comes the building scheme, and
Go ahead and zoom in closer. It's really hard to see on the big screen. And what sort of parameters do you have?
so some of the parameters is the building height or the story height. Very much, I'm telling it to be 10 feet of height for each story, and the maximum number of stories I'm asking it to be 10, and the minimum as well. So in this case is 2. That's pretty much it. And the last one is just the radius of inference.
Okay, so we can decide if we want to, how close we want to have the attractor, or how far out the attractor can actually exhibit that influence. Okay, great.
So this is what it looks like. Pretty much we are using a blow code in order to create this set of rules that will allow us to create the height for each building. I'm just going to open one scheme, a different scheme that we use. And this one is not as linear as the one that you saw before. This one has like an exponential behavior. And if other people could add other set of rules and make the height and the width and change the height, the width, and the length.
So as we're opening it, what this sort of exhibits is, one of the nice things about this very modular workflow where all these things are sort of chunked up is that you can now start having several people working on the problem simultaneously. So like yesterday, Xiaohong was working with different variations on what the height generator was like exponential, reversed, kind of putting damping factors in it. Or to your point, it'd be much more interesting if we have to start putting in some other variables that were more complex than just going through and doing the height. And the nice thing is, the overall workflow will stay the same. It's just you just need a new module and some inputs to sort of feed it in terms of what the parameters are that are affecting it. But the overall flow of the lots, and ultimately the analysis all stays the same.
So is it like generating these masses and then the next script or the next graph is taking those generated masses and then iterating upon that using a separate definition? So you have one definition that generates the masses in one file, and then in that the next one?
That would probably be even smarter. We're not doing that right now.
I was just curious, trying to see how you're actually like switching out the modules. I wasn't right.
Now we're doing the generation and the setting of the parameter height at the same time.
Okay.
Yeah, or in the same module, but yeah, you're actually right. It would be smarter to actually sort of separate.
Oh, I don't know if it would be or not. I'm just curious. Yeah.
No, this is the first step is when we are placing the buildings, but before we do that, we try to implement the set of rules for these buildings before placing the buildings in the nodes. So that's the last step that we do. so the last step, you mentioned before is placing the buildings. Obviously, these buildings are, the only thing that we're changing in the buildings are the height and also the angle of the building, because we want them to face the street where the BART stop is located. But obviously, we could change the width by using the setbacks of the loft and so on.
Very good. I like the notion of, if we have like local attractor points, little plazas and things like that, being able to start changing the setbacks to kind of create those little indentations that make kind of for a nice urban fabric. And again, it's just all just adding more complexity to it, and we're trying to figure out just a way to kind of scale it up one step at a time, so we keep on testing kind of richer and richer algorithms.
Yeah.
So this is the linear relationship that I talked about, the attraction point. As you can see, you can change the height of the building this way, and you just go to
Quick question. Have you read the book Master Planning, the Adaptive City? It's a book by Tom Verbees, who's a assistant professor at the University of Hong Kong and the Architectural Association of London. Essentially, it's basically a pretty hefty book about how to parametrically script cities. And we're obviously, in most American cities, the applications for something like this might be limited to sort of, say, 20, 25 acres. But when you look at the applications towards China, Southeast Asia, many of the cities that are master planning at a much faster rate, you begin seeing that at the scale of, 500 hectares at the, some of the larger sizes that we've sort of seen. What's unique with sort of bringing this into this framework is if you can also bring in some of the more intelligent aspects of energy, the environment, and some of any other suppliers. Yeah.
Fantastic. Then we should get a hold of that and really start thinking about how to start encoding some of those strategies, because the idea of the intelligence is out there. It's just a matter of trying to put it into a form that makes it easily accessible and testable.
Right.
Cool.
So this is pretty much the
Master Planning, the Adaptive City.
this the last. One of the last steps that we do is just to place the buildings into the lots that we have created before. As we did with the other ones, we created these custom nodes where you could anyone could use to plug it into their system. The only thing that you have to input it, obviously, some parameters that you need. In this case, the only thing that we are changing is the height of the building, and automatically changing the building rotation, which is just based on the previous angle that we calculated.
Looking at all this spaghetti code and all the even modularized spaghetti code, it's still really hard to do. So if anyone wants any of these nodes, we'll give a link to that to Caesar. You can post it. You can download all this stuff and play with it. It's just a bunch of little modules that are sort of implementing different little sub-strategies, and because of that, you can kind of start swapping out and playing with different things pretty quickly. But this side's definitely been very much on the generative side of things, just trying to generate lots of alternatives. Okay. So, maybe switch over. Next one? Or the other one that shows the energy?
Yeah.
Do you have a picture? The Revit model or just the energy?
No.
Okay. Let's go up there and let's show it. You got it, and we'll set the stage what I'm going to do.
Okay. So this is sort of the last step when we're trying to test several different buildings at once. And For this one, we also created a custom node as we did before. This is more, yeah, we created but it's trying to use the information of every single building, automatically creating floors. It's trying to also figure out the energy use intensity, but there are other things that one can maybe can test the buildings. So this is one of the things that we did before, and it turned out to be okay. As we saw on the poster, we were able to calculate the energy for each building and also for the whole development that we created.
Super. Okay, so let's put that back in context. Look at that poster again for just a second. And so basically, we're kind of down to this part where we generate the building, we're doing good. We can go through and analyze. Okay, honestly, like energy analysis takes quite a while for a field of buildings like this. You can sort of say whether it's really meaningful to do it across the entire site, how much those buildings are influencing to each other. You know, when we do daylighting and our sunlight analysis, that actually, you see more of an impact in terms of how they all start shading each other and, you know, affecting each other's performance. But the idea really is to extend it from here with continuing to implement a lot of different sort of types of analysis on top of that, and ultimately get to the point where we have those frontiers so we can start to understand what the trade-offs are and try to figure out really, you really like to just sort of put in the city planner's hands some sort of dashboard where they have easy ways of understanding the impacts of the different strategies they're talking about. And just get some real feedback about what those impacts would be as opposed to just sort of imagining. So relevant in doing a sort of semi-major development sounds a super relevant when you start talking about doing these super these major megacities just planned from scratch around the world. Okay, so the first part was just really generating. Where I'm going to take off with this, though, is thinking about the evaluation side, because we did some work in class, just having people evaluating different building forms and trying to use the same very modular approach to implement a number of different evaluation strategies. And there's so many different metrics you could use in thinking about a building. We could think about the cost, we could think about the value of the real estate being created, we could think about the energy, any number of parameters that pull off, we could think about the daylighting, about the insulation that's available on the surface, all these different things are there. And the idea is, at some level, you want to know all those things and have them in a really nice sort of form so you can kind of compare them all and sort of understand different things. So using just Dynamo and some of the conventional tools, we can iterate through a lot of examples and evaluate those different things. You can imagine even better tools that might be worked on that would give you very great insight that would be great to be able to pull out of Dynamo and launch from Dynamo so we can get like even a richer range of values computed for you very automatically. So what this has been very good is generating and alternating forms, but in terms of thinking about all the different alternatives, we really like more insight on these things. So let's go ahead and show you what we did, and I'll just leave that as a hanging question for a friend of mine, because we never talk about future development plans.
Oh, I'm not tied to an annual release. I can talk about whatever.
Oh, that's awesome. Because what I'm going to do is going to whet your appetite for something that would be so much more interesting. Okay, let's go ahead and I'll just pull up a very basic building form here and show you sort of how we approach it in this kind of very modular way. Okay, close it out.
Quick question.
Yes?
Have you thought creating a package for those nodes that you custom created? I mean, it would be a good way to...
It would be a great way to do it. Honestly, we just haven't gotten there, but it would be a great way to do it. So I totally appreciate the spirit of that. I love the open sourcing, and Lord knows we benefit from Zach's work and Lunchbox and Clockwork and everything else, so we kind of owe it to the community to kind of put some of that stuff back out there. So I think that'd be a great thing to do. Okay, I'm going to go pop it out, but in the meantime, I'm going to give you a link. So you can be our open source hub for now. Okay, I'm going to go into this little tower metrics exercise. I'm going to bring up something that may look vaguely familiar to you.
Thank you.
Okay. There's been a building recently opened in New York that somehow has a form that looks somewhat like this. And, we can go through and kind of adjust different parameters about it. And that's the idea. Ultimately, if you have good parametric models, we can start tweaking them and doing different interesting things, whether it be the height, the base. I had this, one of the variables we were playing around was, it's this tower flat side. It's kind of, at the peak of the tower, if I call that the flat side, really, how much flat is there versus the kind of angular side? So going in there, again, this is some really easy work you can do in terms of creating a parametric form and just giving yourself, hopefully, nice ways to sort of test that. So let's see what that looks like. The energy level's turned on right now, so it may take a minute to regenerate. I should probably turn that off. If I had any sense, that's what I do. Okay, but the idea is this form is a good one to experiment with, and we can start thinking about changing different things. We can change its height, we can change that whole issue of how peaky versus flat the sides are. I do a lot of work with twisting. I don't know, I love to twist towers, so you do these things where you have Shanghai Tower and you twist it around. And, the whole world seems to like twisting towers these days. I'm sort of stuck on that theme. So, finish up regenerating already. So I wanted to actually show you the Dynamo behind all this. Okay. The idea is, we got some different building forms here. I'd like to take some parameters, whether it's that flat side or the height or something, just do something to change it around and really quickly start getting some input or feedback about different things that we'd like to measure about the tower. So we could plot those all out in Excel or maybe kind of put them into a more programmatic algorithm. So lots of work to be done here. The idea with this thing, let me just zoom on out, and let me turn off the energy model, or actually turn off the visibility of the energy model. Actually, I should do the other thing. Where's my analyze? There it is. No, I think it's programmatically created. Interesting. Why can I still see it? Oh, come on, you. Okay, that's better. That's going to be a little bit lighter weight. So, we got this thing hanging around in here. In terms of evaluating it, what I actually do is I usually make it shorter, just because, at its full height, it's just sort of a hefty tower. There's a lot of data in there. So I tried making it something a little bit shorter, like 500 feet tall or something like that. And don't tell the folks in New York. So we'll just shorten it up a little bit. Okay, and that'll just going to help it reduce the metadata. General rule, whenever I'm debugging this stuff, and we go around this all the time, when you're debugging things and things aren't working right, don't try it with some gigantic data set. See if you can get it to work with 3 things, because if you get it to work for 3 things, it'll probably scale. But if it's not working, you don't need to find out about that 1,000 times. So definitely go ahead and kind of stay lean as you're doing your debugging. So there's my little lean down version of the tower. The idea is we are now going to go through and use Dynamo just to evaluate some different stuff. So hang on, oops, looks like Dynamo's still hanging around. Close that up. Open. I'm still getting used to the fact that it's under the Manage menu now. It's just one of those things. Is there a keyboard shortcut for that? Okay. I'll go on out. I'm going to bring up, where's my SFDUG folder? You're here somewhere. There you are. The master control behind all this is just a very simple thing. It says test tower forms and report metrics. So let's go ahead and show you what that script looks like. The idea is, at some level, we are going to go through and do something that looks like this. We're going to have some very simple inputs. We're going to, in this case, I'm just going to change the tower height so it could be any of those variables. There could be combinations of those variables. But there's some node that I'm going to use to just take these inputs, sort of a form. We're going to take some inputs of a name of a parameter that I want to flex, could be multiple parameters, and pull back out some sort of reporting parameters. So that's pretty much it for a lot of what's going on in here. At a high level, we want to do that. And the idea is to wrap it up in a list map, my old friend, because List map will let me go through and for different either single values or combinations of values, go through and kind of do a bunch of different tests on the tower in that combination. Okay. I actually like to go through and put everything into a single kind of master evaluation node, just because in terms of the list mapping, since every time you regenerate the mass, okay, it takes a hit on processing time. It's better to sort of regenerate the mass and do all the processing on that version than regenerate the mass and do all the processing on that version at once. Like multiple list maps just really slow things down. So a little bit of play there. I have a couple of other parameters down here. These are just related to a little bit of Green Building Studio. We have just a name for it out on the server. Let me even go ahead and give a slightly different name. And then also a place where it should temporarily put some GBXML files. Because even though you don't think about it doing that, it actually needs to do that somewhere to kind of get things done. And it just usually hides that from you. Okay, so the idea is we're list mapping to evaluate some different alternatives. At the tail end, all I'm going to do is basically take the data that's coming out and just write it out to Excel. Because Excel's a lot easier for most people to understand and work with and kind of the grid structure. So let's pull back over here and take a look inside this node. So in here, in my little modular world, I can go through and edit that custom node. There are a series of different evaluators, and the way we sort of look at this is over on the side, there's just inputs. Okay. Based on those inputs, like the model element, which we've selected from the Revit interface, we can go through and based on an input parameter name, start plugging in values. Those values will be varied by the list map. So we'll go through the different range of values. The important thing when you're doing this is this whole transaction start, transaction end thing. So when I set the parameters, I have to end the transaction so the form will regenerate before I can actually start pulling the evaluations out. And that's not only the slow part, but it's this very necessary part. So when I'm working with students, if we forget to do that transaction start end thing, the script races ahead and it grabs all these values, but the form itself hasn't caught up. It's still back there on iteration 1 or 2. So you get sort of bad values. So this whole transaction start, transaction end thing is very critical in terms of varying the form. What I do is I put the form in as the input for the transaction, and I take the form out as the output for the transaction. It's going to be just passed back through in its new, improved, altered form. Okay? And then we pass that form down to a number of different sort of evaluators. Everything from very simple things like, hey, let's just get the gross floor area, which is just a parameter read. So we can just get the parameter value by name. We get the mass, the list of mass floors at each level. That's actually sort of an interesting thing about doing that. Yeah, there's its own sort of like a custom node for doing that, about element returning the mass floor areas. And you can kind of pull that out or something like that. Pulling out the mass floors involves just a little bit of work, and I embed a lot of that in sort of this custom node. But the actual area of the mass floors, and it was really sort of an important thing to have. The reason being, I just don't want the total floor area. If I want to think about real estate having different values based on which level it's located on, and the cost being different based upon which floor you're building on, okay, that starts to give me the ability to, whether I'm doing a simple linear kind of interpolation or I'm sort of targeting specific floors based on their values, I can start doing a little more sophisticated evaluation based on what I'm creating. So I bring in the model element, I get all the mass floors from the model, I try to match them. You'll notice right up here it says broken because as things happen, as you move between different versions of Dynamo, things break along the way. And that one I'm still debugging to sort of see what's wrong. So I've temporarily bypassed it, but I'm going to leave it hanging around in there because I'll get that fixed someday. That little one in this model is not so bad. It was more critical to Rommy's model. It's basically making sure that the mass floor belongs to the mass. Okay, because you might have other mass floors in that. But not too critical here. And then out of that, we're just going to get the floor areas and report that out. So what happens is I use that as an output. I'll get a list of the area on each of the different floors, and I pipe that into something that will either compute a total cost or a total value based on the height. So we'll get some floor areas, very similar to what Ronnie did with the kind of distancing function. There's sort of a cost at the bottom, a cost at the top, the overall height, so we can sort of subdivide it, and we'll just then scale with a little linear interpolation. Again, that's not necessarily a great model. We could do more of an exponential or something that's based on a little more data. That somehow this floor is above a certain level, so all of a sudden the values got to be much greater because we have a view opportunity that we didn't have before. So we can play games like that. Okay, again, just by swapping in different nodes. What's happening at a high level here is we're varying the form, and I'm just running it through a bunch of different evaluations. And I love these different groups as a way to sort of organize and kind of make it more easy to see what's going on. So I'll do the cost, I'll do the value. The ones that I think are sort of especially interesting to some of us here who spend a lot of time thinking about energy and that sort of use are things that are basically encapsulating and running the energy model, or even getting the insulation values, or maybe some other tools we can go through and plug into. So here's the idea here. We've taken the whole energy model and really sort of encapsulated it in a node. So if you feed it a mass, and I don't have it turned on right now, I should plug it in there. And you go in here and say, I would like to edit that custom node. The whole energy model is sort of encapsulated in this, which is very similar to what Rommy was using. We have a couple of inputs. My inputs are actually just the name of the GBS file that I want to create and the mass family, and certainly those things. Based on that, I take the masses. They have more than one of them, okay, as we had in Rommy's case. I'm basically going to divide them up into levels, and then based on that levels, I'm going to create some zones. And we're going to export some GBXML based on, I can either do it based on the zones, or I can actually do it with the masses themselves. I'm going to export the GBXML based on the zones that are created. In terms of, a file path, it needs a temporary place to stuff GBXML files. And it needs to even give them names. So what I do is actually pull in a file path, and this whole little funky part over here is really just about, if you've got a file path, I'm going to go through and create different test case names. So the 400-foot tower is 400, 410, 420. It's just iterating, so all the GBXML files have unique names, otherwise they're going to run on top of each other, and you won't be able to evaluate them all simultaneously. So you write out some XML files. That part's doing so good. At the tail end of all this, we say, let's go ahead and run the energy analysis for each GBXML file. It takes those into the big list, it runs and sends it off to Green Building Studio. Okay. At which point, you wait. And wait. And wait. Now the good news is, right here there's actually a parameter that lets you choose whether to do all the parametric runs or not. Okay, so if you only want the base run, you can leave that set to false versus turning it on. That speeds things up a lot if you don't want to think about all those until we get better tools that evaluate those floors automatically. Okay? But at the tail end, you're going to get some results. And here's where, there's choices here about how to go through and do this. You can try and get your looping to wait on the results from the GBS server. Okay? But honestly, I have a really hard time getting that to work. It's supposed to wait. There's even a parameter that says, wait, don't do it yet. But it rarely works. Oftentimes, if you sort of pull the analysis results right away, like the Dynamo is not waiting, something's just something about the server communication, and it's not quite connecting. So the way I started working with the students doing it is just return the run IDs, because 10 minutes from now, after you've had some coffee, I can go back and pull the data based on the run IDs. Okay. It also has some effect on just your analysis, because waiting for it to run 100 different iterations could mean that your overall looping scheme is going to take an hour, where this way it's pretty quick. It just gives you the IDs back, and then it goes from there. Okay, so that really just sort of encapsulates the whole energy workflow really quickly. And the nice thing I like about doing it in sort of a separate node is, if I decide to change something about my overall strategy, again, I can change it in the node, and not have to worry about kind of all the different types of analysis that are depending on it. So somehow we can count on this node to, if it's advertised right, give us the right results. Okay, in a similar sort of way, over here got a little node down here, which is, I should encapsulate that a little better. It's just all about doing the sunlight analysis. So we bring in the element, we bring in the location and the sun settings from the current project. Based upon that, we sort of feed the weather and the time study, and we ultimately get back some sort of evaluation of the insolation on that surface. So that node encapsulates all the solar analysis functionality. So back over here, it's pretty much just feeding the solar radiation analysis. I have a lot of watches hanging around in here to see if things sort of get messed up as we pass between the custom nodes and the higher level nodes. Things to watch out for this one in particular are this whole analysis grid spacing can be big. I should probably pull that out to a higher level because on something as big as the Freedom Tower, like when it's set to 2, okay, you just get millions of points really, really quickly, which really bog things down. Whereas for the scale of this tower, every 15 feet is probably okay in terms of getting enough data to sort of, at least at a high level, evaluate what the best alternative is. Okay. You run the solar analysis, it pulls out some results, the average, the peak, or the cumulative, whichever you sort of want in terms of the solar insolation or the numbers. And then you've got to decide what to do with those. You can either add them up, you can average them. There's a lot of things you can do with those. It's actually a big list of numbers because it's the whole grid and all the different insolation values. So you got to decide what are you going to do. What I did was I actually sort of averaged them per surface and report that back. Okay, but you could sum them. What someone pointed out in class, which I think was actually good, is that he said I should actually do a weighted average. So somehow get the average, then apply it across the area, because that would actually be a truer value than just kind of, the raw average itself isn't necessarily important because some areas are very small. But again, that's all changeable within the node. So when you get all done with that, we report it out, and hopefully you get some values that are floating around and actually popped out to the Excel spreadsheet. So when you run this, and I won't run it for you right now, I can, although that's always risky. Let's go over here. What you get at the tail end of this is something that just looks like this. We have the different testing values. Looks like some more junk from the last time I run it. It's sort of showing up down there. But the idea is you have some test values, you get the reporting, let me try to zoom that up so you can actually see it a little bit better. The test value, that's the input value. In this case, it was the tower heights. You get the gross floor area. You get the cost metric based on whatever formula you were kind of using there. You get sort of a value metric. In this case, it looks like I messed it up because that's looking like that's the insulation value. That's not the energy run ID. I should go ahead and rerun it and kind of put that back in there because I actually want these numbers to show up over here. So let me just do this. I'm going to kind of clear those out. Okay. And I can rerun this thing again. If you do rerun it, come back over here, up to the highest level. What I will do is, what am I going to do here? Just for the speed of debugging, I actually took out the link into the energy analysis node, just because, again, that's always the slowest one in the process. I should probably put that at the tail end of the process. Let's see if I can get my mouse back. If I really want to be fair about this and finish it out right, what I need to do is connect that mass. Actually, I won't do it. It'll take the time. I'm not going to do it. Well, I'm always torn. I do this in class, too. It's like, should I? Shouldn't I? I want to show it to you, but I don't want to sort of waste your time either. So back out here. Take the mass, the altered mass, pull it on down. It's going to be the mass that feeds in here. Oops. I just screwed that up. I should move that the other way. Okay. Let me go down and see what I messed up. Oh, that's supposed to be the test string. It's the title string. Let's bring that over. That's easy to fix. And at the tail end, in terms of reporting the data, what I need to do is just put the column back in. So over here, I just pull all those values, do a big list create, and we pull that one down to the tail. and then get the energy, the run IDs, not the actual energy number, but the run IDs, because I don't got the time to wait for the other. Okay, and that'll let me write all this stuff out and populate my spreadsheet. Okay, so if we're feeling really daring, we'll do a save. Never do things live. That's how you get in trouble. Okay, and we'll say, oh, just to sort of see if there is any difference here, go over to my inputs and say, oh, let me change from, I'll go from 500 to, again, I'm going to start to be really simple because I don't want to waste your time, 530. So I should get a couple of data values in there. 4, as a matter of fact. Okay, save that away, run it, cross your fingers, pray, get some coffee. But hopefully, actually I should have moved that out of the way. Yeah, you can, I actually like watching the tower dance around in the background. It's actually kind of fun in a weird, reverse way. Okay, so that's going to run around. The tail end of all this, just because I'm leaving you hanging with those running IDs, and that isn't actually the value you want, is that you actually need another script to go through. So I have another graph which actually pulls the run IDs and then goes out and gets the results. Okay, and I'll live with that kind of asynchronicity just because what I can do is basically go down and read the run IDs from the Excel spreadsheet, have it go out and query the GBS server, and pull down the actual values I want. But it's definitely sort of a known weakness in the scheme, but given the trade-off, I think it's worth it. Okay. Come back over here. Let that run. Come back over. Never mind me and my machine. Okay, it's still running. It's going to be doing its thing. Actually, if you like to snoop on things, you can do things like this. And I'm a snooper. I'll be the first to admit it. Go out to the desktop. If I go out to the desktop, this is actually a pretty good debugging technique too. Go to the GBXML files, sort of see if they're being generated. Actually, I can see 500 and 510 are out there already. So it's working. It's just kind of doing its thing. So just keep track of it. You can also go over to Green Building Studio and see what's going on. Oh, one highly recommended thing to do if you are going to try and use the energy node through Dynamo. Try running it just manually through Revit first. Because a lot of times there's just some problem with your model, and it's not going to work out right out of Revit. It's certainly not going to work well out of Dynamo. So you can either run it directly through Revit, just by kind of running it in the cloud, or even better, try saving it out as a GBXML file and uploading it to GBS. That will really be the truest match to sort of see what's going on. And then you can spend all your time then figuring out what it is about your form or your shape that just isn't running. So when you get these weird nulls or something, it's not the scripting. It really is just something about the energy model. Okay, down to 520. Okay, they're getting pretty good. When it gets to 530, I think we're actually maybe in good shape. But again, let's not belabor that. Yeah, that's kind of the gist of what we wanted to show you. Is sort of these nodes and kind of this overall workflow. But the overall principle we want to drive home is really that this whole idea of modularizing and kind of really kind of thinking about it more about this in a structured programming way really adds great value, because as much as we love the fluidity and the easiness of Dynamo, when it gets to be sort of a big project, it sort of gets very hairy around the edges, and you really have file management problems and kind of sharing problems. So a little bit of a structured programming approach where you think about the modules like subroutines, and you think about all the linkages being like little APIs, really helps a lot when you're trying to get a lot of people working on something and incrementally build something that has a kind of different degrees of complexity. There, run completed. Nah, really? Okay, let's take a look. Actually, go over to, there's the GBXML files. Excel. Hey, check that out. Values, we got cost, we got value, we got energy run IDs. Okay, now, the question is, what Green Building Studio is up to, and it may still be working for right now. You can always check on it a little bit. You can go out and do the little Green Building Studio kind of look-see. gbs.rs.com. Sign in. I'm always signing in on the Mac side.
Are you running on Parallels?
Yes.
How's that performance?
Oh, it's been fine.
Yeah?
So what do I do here? Yeah. Everything with the Dynamo stuff, I never really sort of see much of a degradation there. I know there probably is some, but I think the problems probably are less related to that than my problems. Yeah. I switch over to boot camp when I have funny, intensive graphic things to do.
Mm-hmm.
Yeah. Okay. So you can sort of see, oh, project 2 is right here. There's 4 runs working away here. Hey, there's data. Okay, we can test our other things. So despite all my bad mouthing, there's potential. It seems to have done its thing. So let's go back and give you the final script. That is over. Where'd it go? Revit. Okay. Save your changes? Sure. Save your changes? Now you make me wonder. Sure. Hey, now I'm really getting worried. Oh, come on. Okay, let's go back out. I talk to my computer a lot. It's kind of an occupational hazard, I think. Actually, I did need to close Dynamo. That was silly. Let's go open. The function I want to show you is fetch energy results, right there. And fetch energy results is actually not too off the bed. It just sort of, go back over on the side, reads the data file from Excel, isolates the run ID values. I got to figure out where they are. They're like in column 5 or 6, so I got to find them right now. Gather the desired results. This is back to the energy analysis nodes. I feed in run IDs. Then I just figured, hey, give me different things. And I chose to get the net CO2 emissions and the annual energy cost. This is 2 different values. I kind of do a little bit of transposing to put them back into sort of like column order. And then I rewrite them back out to Excel. Okay, so no telling what's going to happen, but it should be quick. Should go to Excel, read those values, go out to the GBS server, pull down the values, and then write them back out to Excel. Looks like it grabs some values. That's looking pretty good. Oh, I see a warning in there somewhere. Lord knows. Ah, that's interesting. Null cannot be matched. Let's see what it did. They got some stuff. That looks good. Maybe something about the range. There might be something I picked up something that I considered to be valid data here, and was reading it as a null, and it didn't match it to a run ID or something like that. But it did do okay in terms of actually going through and picking up this stuff. So that's kind of it. It's just going out and grabbing the different data and putting it together. Okay, so that at a high level is what we wanted to show you. Just, you can use Dynamo to do some really cool generative things. You could use Dynamo to go through and do all sorts of evaluative things, but somehow the combination of those 2 things lets you sort of really quickly start evaluating design strategies and hopefully getting some insight to help you. And it'll only get better as those better analysis tools become more and more available to us. Because, at this point, as long as we can connect to them, we get good answers and use that data to go through and guide our exploration. Yeah, that's it. Thank you, one and all. Any questions? And we'll give you the link so anyone can get all this stuff.
Can you point again what's the node that accesses the Green Building Studio server?
Okay, so in that, there are sort of 2 different nodes. Let's go back out to, there's one that sends it to Green Building Studio, there's the one that pulls it back down. So the one that pulls it back down, which is showing this error because of the null right now, but it's right here, it's just basically get analysis results. So what I'm feeding that is just the run ID as opposed to waiting for it. And then out of that, results comes as a type of data object. We can then sub-break that into specific types of results.
Great.
Okay. The other one, I think, is running the analysis. But there's something about separating them that really, it sort of increased our reliability quite a bit. The other one that I should comment on, that the students played around with quite a bit, is the daylighting one. Daylighting was a harder one. It's just like, it was more just the server itself didn't always give very reliable results, or sometimes it seemed to get bogged down and stuff like that. So we've had less luck with daylighting. Okay, but for energy analysis and solar stuff, it's pretty rock solid.
So I know for the daylighting server, there's a separate student queue and a paid queue, and when you do large batch submissions to the student queue, you're likely to get bogged down. So that's
Well, that actually makes a lot of sense. And since it's all free to the student, we have no room to complain, so that's okay.
Yeah, so I think if you do batch runs to that student rendering queue, it'll probably easily get bogged down.
Makes sense. Makes sense.
Try it smaller.
Oh, please. Students don't try small things. No, we're going to try every variation.
You're doing like 100 at like high res.
Exactly. Yeah, it's free. Why not? Just do it high res. We've got nothing time on our hands. No, exactly.
Probably a greater likelihood of success if you do smaller batches.
Always.
Like a medium.
It's the voice of great wisdom over there. Okay. Questions, comments, anything. It's like that. Yes?
Do you have a general rule of thumb for when to make one of those combination nodes?
Like just the custom node?
Yeah.
It's really whenever the functionality is separable, and I really want to treat it just as an input and output. And part of being separable is that I might want to swap it out easily as a chunk, as opposed to having to sort of get back into all the code and isolate the interfaces. So it's kind of like a discrete operation. If I was doing a step list, if I can put a number next to it and say this is a discrete step, then I think it's a candidate for a custom node.
Do you cartoon out like the graph and have like bracketed input output type things where you can think about like, okay, this would be the likely place where we want to swap something out based on what we know? Or
I would say that would be a very smart approach. I think later in the process, we ended up doing that and understanding it. Like, they're like so many different things. This sort of evolved organically. I think we started out just started blasting through it from one end to the other, and only halfway through realized that a modular approach was really almost necessary for survival. So now, moving in, that would be a very good approach. I would highly recommend doing that.
it's a really interesting workflow to break it up this way. Like, I think there's a lot of potential there, especially like the collaborative piece of it that you're pointing out. I think that's something that I've heard from some of my teams too that are trying to use it is how do we collaborate on a definition like this when it's like you're kind of plugging and playing with this massive thing, but we have a hard time understanding like where are these logical breaking points where you can test out this subroutine like you said and be able to plug that in later. So that was really great to share that and
Thank you.
incorporate that somehow, I think.
Yeah. Somehow it seems like there's a good lesson in here somewhere that we all start applying, because I think all this stuff's getting more and more complex. And
we're always running up against the just data pipeline and like how to push out and get that massive amount of data, and like those kind of strategies are really important, especially if you have ways of like showing how you output the results into the Excel spreadsheet so that you can query that spreadsheet later. That helps you avoid a lot of those errors or having issues with not being able to push enough data out in a meaningful amount of time so that you get runtime errors or other things, those kind of like infrastructural strategies are good to see.
Mm-hmm. Mm-hmm. I think that's really a good area for development. I would bet, and this is a good thing to ask Zach about next time,
Right.
2 times from now, is really, as this, because we need more nodes to do specific things, but we're sort of running into workflow issues now. Which makes sense. As things mature, you kind of get to that point where you do.
Yeah, that's something. Go ahead. Sorry.
Yeah, I was going to ask sort of a related question, but at what level or embedded in this do you have actual code versus nodes?
This is almost 100% nodes. We didn't write any Python. If there is any kind of code in here, it's only because we've kind of picked it up with some of the standard packages or something like that. So no, it's all just been nodes.
I mean,
Yeah.
that might speed up some.
Oh, clearly.
Yeah.
Clearly we could like start sub-optimizing some of these things and just really, okay, this is a particularly slow operation. Could we use a little coding to really ramp that up?
But the plug and play architecture would facilitate that because you just would optimize a single block and not have to optimize it.
Yeah, it's really just being able to break it apart. Just because for so many of these different things, we would run things and it would just go check out for 45 minutes or an hour or something like that. And no one had the time to kind of sit around and wait for it. So it really just became survival about having to find ways to sub-parse the problem and find intermediate ways so that you just didn't have that huge dependency.
Can you elaborate on that transaction start and stop and the
Sure.
generating the form and saving the
Sure.
processing time?
It's a kind of real classic list map problem. So if you're doing list maps to kind of change some sort of form and you're trying to evaluate based on that, it's really it was one of the first major mistakes that I was making that I really had to kind of find a way around, and that was really when you're trying to go through and change a parameter on an object in Revit, it won't regenerate automatically. You have to go through, or just based on the fact that Dynamo is tweaking it, you have to actually sort of tell it that you need to regenerate and have it regenerate before we read the value back out. Now, there's a bazillion different things you do in Dynamo that don't really require the Revit objects, but a lot of what we do uses the Revit objects and the geometry engine just really as a calculator. So it's very important that you have to just plug in the values, let it do its thing, and then pull the values back out based on what the object did, or the element did. So this whole transaction start and end, it really just says that before it's going to go through the end, whatever you passed in, we're going to wait for it to finish updating, and it'll complete the regeneration. So this element, even though I pass it in every iteration, it won't really be evaluated until that transaction is done. So it'll set the parameter name and regen. Okay, and then after it regens, we can figure out what the area is or what the new form shape is.
So you couldn't just plug it into element and then have element come back out. You're finding that downstream was getting ahead of itself?
Yeah, exactly. It gets ahead of itself because what will happen is it'll race ahead programmatically, and you'll get the symptom you'll see is that the results of your list map will all be the same values, or maybe change at some weird spot later on. And it's just because the Dynamo code is so fast versus the Revit regenerating. It just it goes and queries the value. Oh, I got a value, but it didn't actually wait for the update to happen. So, if you're messing around and reading values out of Revit, that just plug an element in, make the change, and at the tail end, go ahead and have the transaction end to make sure it regenerated before you got to grab the new values in.
So is that kind of like an intuitive discovery that you made, or did you get?
No, that was like digging around. It's like, in fact, even I think that's changed a little bit through the different versions. There used to be other functions that had more waiting for things to complete sort of actions, and those sort of got deprecated and dropped off. But no, if you need something to change, need the values of the change thing, we're looking for transaction start and end. It's the same thing. If you were doing this Revit API programming or something like that, it's the same notion. It's just you got to set some values, and that forces the regen, which causes the object to update and the data elements that are available to you to update with new values.
That's really interesting.
So that's like if you leave a manual, you go change your massive shape, you come back, hit run. Would you bypass the need to do that?
It's whenever you do a set parameter, and then you're going to get a parameter that actually depends on the object updating before you do the get, put a transaction start and stop in that. So it's because if you just did the set and then did the get right afterwards, you wouldn't get the new value, you'd get the old value. So weird stuff.
That's totally weird. Yeah.
That's why we have a community for sharing this stuff, because I think we've all learned, and Zach and Andreas and everyone who's, there's a lot of people who share a lot of good stuff, and we're all learning from each other.
Yeah, I think you might have just fixed the script I'm working on.
I
was just thinking
I'm looking forward to
All the better. Okay, cool. We are wrapped, so whatever you would like.
Any question?
Okay, we'll send you a link to an archive. Anyone can download this stuff and play with it.
Yeah, you can email it to me, and then we could connect it to our
Put it on somewhere on the site where the
Right.
recording notes are. The
Yeah.
real seminar.
Is there a write-up for that issue you're talking about in terms of putting that clip before with the start and stop?
Oh, there must be, because I didn't make it's just do some searching just for transaction start and transaction stop, and you'll find it'll be stuff that sort of came out in like one of the the early releases. That was the first year of Dynamo being out. People ran into that one. So find people talking about the need to do that back then.
Thank you.
No worries.
Thank you.
Our pleasure.
Thank you very much. I don't think, is there anyone on the line has any question? Let me know. I can unmute you. No. All right. So thank you again. I'm going to close the session.
What do you think the next step of that land use generation that you're doing? Would you think about maybe like analyzing what's already present? I guess the reason is like I'm curious of like testing what has been established in building code and actually
Thanks for using WebEx.
like
Visit our
querying it for whether
website
it's
at
like even a valid way to
www.webex.com.
plan cities. Like there's a lot of assumptions that are just made on like can't have this next to that. We have this like sky plane issue like at least in the city. They have like light and air. This is basic limits.